Alright, this is our first lesson of Chapter 11, and our learning target is to be able to use the correct language and notation associated with functions. So, today in class, I had you answer a few questions, such as, if I have f of x equals 2x plus 1, find f of 4. And you all did this very well. You remembered that from our prior chapter, you substitute 4 in for x, and you can find your answer that way. So f of 4, in this case, is equal to 9. Okay, this is how a lot of mathematicians use function notation, because it tells what your input is, right? In this case 4, and what your output is. So a lot of people equate this to a machine. You're putting something in and you're getting something out. But technically, when we say the function f of x, that's not technically mathematically correct. A lot of times we'll say the function f of x or the function g of x, and we all know what is meant. And a lot of mathematicians do this, but technically this is not the right way to describe functions. And, you know, Cambridge really likes us to use precise language and a notation that's very specific in terms of meaning a function rather than a straightaway output. So what I mean by this is when we say the function f, that differs from the function f of x, because f of x technically isn't a function in and of itself. So our new notation, which is somewhat interchangeable with the notation that we've learned in the past, is the function f, and it's separated by a colon. So this means f is a function, right? And then we do this, okay? So this means f is a function which turns any input number of x in the domain into an output number, and this is our output number. Okay, and this is the example used in your book. So f is the function which turns any input number x, that's this, for this function into an output number. Okay, and again, they do throw in a function within the domain, because obviously if it's not in the domain, it doesn't work. So we could have a function that looks like this. We know that f is the function f. There's no x attached here, right? Because this is the absolutely positively correct way to write this mathematically. And also, one other thing before we move on, you'll notice that this arrow, sometimes in math we do things like this. This means tends to in math, but when you put a blunt end on this, it does not means tends to. It means kind of which turns the number into. Okay. So make sure that you put a blunt end on here, because it doesn't mean that x tends to be in this domain, or value in the domain. It means that it is. Okay, whereas this is tends to. Alright, so what happens if I said from here, what is f of 2? Well, pretty much the same thing happens. We end up substituting 2 in for every x, and we end up with 4 minus 12 plus 4, and that happens to equal negative 4. So our final answer would be f of 2 equals negative 4. Alright, so not too bad. Same idea as what we've done. This is just a different notation. So what happens if I have something that looks like this? Okay, what this means is I have a g is a function which turns, oops, forgot my x, okay, which turns any x value within a domain into an output number for x squared minus 9. So basically, if I asked you to find g of negative 4, what you would notice is negative 4 squared minus 9 is 16, right? Minus 9, which gives me 7. And I could say that g of negative 4 equals 7. Okay, so pretty much the same idea. All right. Finally, what happens if we have a composition of functions? So if I have something like this, so the function f, let's say we have x squared plus 2x minus 8, and we have function g, and we're putting an input in for x within the domain of, let's say, 2x minus 10. If I ask you to find fg of 3, this is called a composition of functions, just like we did last time in our last chapter. And all we do as a reminder is we work from the inside out. So the first thing we're going to do is we're going to find g of 3. Since we're using g, we use our function g. So basically g of 3 is equal to 2 times 3 minus 10. So g of 3 is equal to 6 minus 10, which equals negative 4. Alright, now that we found g of 3, we can replace this for f of negative 4. So basically, since g of 3 equaled negative 4, I'm substituting negative 4 in for g of 3. Okay, so now I have f of negative 4, and I'm going to go ahead and everywhere I see x, I substitute in negative 4. Okay, so when I do this, I get 16 minus 8 minus 8, which equals 0. So f of negative 4 has a value of 0. Okay, so when we write our final answer, we say f of g of 3 has an output of 0. Okay, so we had an input of 3 into the function g. Then what function g of 3 yielded, we input into function f, and we ended up with an output of 0. So this is the only difference in terms of the function notation that we've studied in the past. It's just a more specific, way of looking at, not a more specific way, let me rephrase, it's a more mathematically correct way of writing functions and expressing functions in a more correct notation. Alright, that's all for today. I'll see you tomorrow.